Hey guys, good morning. Welcome to the Fundamentals of Aerospace Engineering. Today we are going to discuss about the case study of the company called 3D Printing Corporation. They have taken the optimization of the components for the additive manufacturing process. Right. So coming to the topic. So this company is established in 2016. It is American based, the owner, and it is now in Yokohama, Japan. So they are the main the company production of the additive manufacturing components. They do the supplement in the digitalization manner. So this company offers four main services: design engineering, including a wide range of additive manufacturing technologies such as power bed fusion and fusion flame fabrications. These are the two methods they are doing their services all over the Japan. The manufacturing is in-house equipments at this 3D printed company is located in the Japan. So the hardware internalization, consulting and digital transformation, where their customer can place their track order electronically. So the overview of this company is A, B, C, D categorized. One is the design and engineering service. Next one is the on-demand parts manufacturing. Third one is the additive manufacturing hardware internalization consulting they are doing. And they do the case studies on their projects and the federals and different regional. And those case studies they will solve different problems. And this is the flow chart of the design engineering. And design they will do the design. With analysis, they will do the computer aided engineering. With that data, they will change the materials and they do the 3D printing at final. With this 3D printer components, they are used to digital MRO solutions. There they can do the weight reduction, part function, lattice design using ANSYS, topology optimization. They will do using ANSYS, meta materials, different shapes and configuration. This can be extruded in the digital texturization and from the 2D to 3D design. So here they have the problem on 3D printing corporation based on Japan, and they do the manufacturing development alternative supply chain by producing a one-stop shop for strategic 3D printing services. Inspired to secure supply chain and prepare manufacture for the unexpected disruption, this company equipped manufacturing with additive manufacturing parts and services to optimize and digitalizations of their works. So this company marketed from a small kid toy company to a space station company. So here they are facing a challenge on the main challenges are this 3D printer company works in the wide range of materials including resins, metals and the composites. Predicting deformation is essential in additive manufacturing to build parts successful and keep costs down and avoid mass printing errors. So they will do the ANSYS multiphysics simulations to analyze and predict thermal deformation in advanced and modified parameters. It is also important to balance the strength and weight of the design additive manufacturing parts. Client seeks the strong parts but also require them to be very light in weight. So this company approaches this using a deposition molding method and integration ANSYS to optimize the process and achieve the better results. So this is the centrifugal airfoil wing model. The design this 3D printer using ANSYS fluid to analyze the fluid flow around a centrifugal airfoil. Then they do the modeling and meshing of the domains, and they apply the boundary condition and they will do the flow over the centrifugal pumps or centrifugal airfoil, and they will get the pressure density and the velocity over the surface, and they use to measure the lift and the drag coefficient of this airfoil. The basic technology they used is ANSYS mechanical, ANSYS LS Dyna, ANSYS additive suit, ANSYS fluid and ANSYS discard. So for modeling and simulation, they do the ANSYS mechanical analysis diagram. Whereas in the additive engineering solution, it is to improve the strength and weight of existing part. This 3D printer company allows the FDM method to use ANSYS mechanical and apply the topology optimization to reduce the part of different components weight and to maintain its strength during this operation. The team avoided the strength conditioning consideration they anticipated and the FDM method to apply this topology optimization model. In one example, using this approach, 3D printer model company has successfully reduced the weight by 20% without reducing its strength. Next, the team accomplished this using ANSYS simulation capability to repeatedly changing settings and parameters such as boundary condition. For thermal analysis, this company integrated ANSYS Flume to evaluate heat change efficiency and ANSYS additive suite to predict thermal deformation using power bed fusion, that's a PPF method. Additionally, they evaluated the shock absorption performance of the elastomer material using ANSYS LS diagram and analysis mesh data with ANSYS Discovery. This is the internal material and data in simulation. The samples are there. First one shows the centrifugal pump model with the aerofoils ANSYS Flume simulation of the fluid flow around a centrifugal pump. Second one shows the ANSYS simulation of the fluid flow around a centrifugal pump impeller. And with this critical insight from the ANSYS simulator, this company can detect possible defects and including porosity in the metal which can be reduced causes when it's operated during the operational process or running process. When it comes to the benefit of this, reduction of 20% of materials and maintaining the same strength and reducing part of weight. Reducing material cost can be less than material. This company produces highly quality parts serviced by the applying ANSYS multiphysics analysis and critical insights. ANSYS fast simulation results enables this company to reduce time of scale, which is accelerated production process and secure new customers. ANSYS simulation helps this company to qualify the hardware and the software of additional manufacturing process such as lattice questions to improve the parts. Present stronger proposal to client with his ability to illustrate parts characterization using simulation. So here there are benefits of this 3D printer company by reducing the weight and maintaining the strength as 20% same and reducing the weight by 20%. So here we are concluding this how this company has successfully done this case study and reduced the weights by 20%. Thank you. We will see in the next class.